So he says, use algebra to solve this equation. 7 plus 2 sine x equals 4 sine x plus 5. This equation just has a sine x. So one of the things I'm going to want to try to do is get sine x all by itself. So if I subtracted 5 on both sides, that would put those like terms together. And if I subtracted 2 sine x on both sides, just sort of putting my like terms together. So what happens on the left side is I'm just going to have 2. On the right side, I'm going to have 2 sine x. Okay? Now this question would appear on a non-calculator part of a test, quiz, or exam, because when I get sine by itself by dividing both sides by 2, I get sine x equals 1, which is on our pie plate. What values do we have? What angles give sine x equals a 1? Just pi over 2, right? Okay. So this is very common. You go through your question, you get sine by itself, you recognize it on your pie plate, and you write your answer. And we notice that we wrote our answer from 0 to 2 pi. Okay? And then we go back to the question, we look, okay, what is the question asking for? The question's asking for degrees, and it's asking from 0 to negative 360. So we might have just solved it naturally by thinking of our unit circle and thinking of pi over 2. It's not hard to switch that to degrees. That's 90 degrees. But now the question is asking from 0, actually from negative 360 degrees, less than or equal, well, just less than, doesn't really matter here, less than x less than 0. So we need to think about going around this way and ending there. And so our answer will be negative 270 degrees. Make some kind of indication that you know that that is your final answer. And then it says, then write the general solution. So for the general solution here, since there's only one answer between 0 and 2 pi, we'll just have that one answer. And you could choose to use the negative 270 or to use the 90 degrees that we started with, plus 360 degrees times k, where k is any integer. So since there was only one solution between 0 and 2 pi, you only have to take that one solution and add 360 times k. Now it doesn't matter which, as long as you choose any solution that works and add 360 times k, because k could add 360 or subtract 360 as many times as you want. You know, if you wanted to use the answer that you found, negative 270, you could have started with negative 270 because it is coterminal with 90 and added 360 degrees times k for any integer. That would work as well. Okay? I personally like choosing the first one between, all the ones between 0 and positive 2 pi or 0 and positive 360 and adding 2k pi because that seems to be what we've done the most of. Okay? And you start to naturally solve these equations by thinking about your pie plate and solving from 0 to 2 pi first. And that's not a bad thing. It's actually a great starting point. But then you always need to go back and look at the domain afterwards. Okay? So I'm going to do the same thing with part B, even though I can see already the domain is from negative 2 pi to 0. I'm still going to solve it first between 0 and 2 pi, just to get you guys in the habit of doing that, because it's not a bad thing. So now we have cos 3x equals negative 1. So I'm going to just start by thinking about this between 0 and 2 pi. This is a multi-revolution question because of the 3x. So if we were thinking 1x was between 0 and 2 pi, 3x's would be between 0 and 6 pi. And that would be like going 3 times around the circle. Now, is -1 on your pi plate? Yes. You get -1 at pi. That would be 1 time around. If we draw our little unit circle over here, right, we have -1 right here. The first time around, you'd only hit it once. The second time around, you would add, if I'm at pi and I go all the way around again, I'd add 2 pi to that. That would get me to 3 pi. And if I had the third time around add 2 pi again, that would get me to 5 pi. So in 3 times around, you'd hit pi, 3 pi, and 5 pi. And that's what 3x is equal to. So if I wanted to find out what x is, I'd have to divide everything by 3, which is the same as multiplying by 1/3. And so I'll get pi over 3, 3 pi over 3, and you don't have to reduce that if you don't want to, and 5 pi over 3. Now those are the answers from 0 to 2 pi. Yes? Okay? So I started by solving them from 0 to 2 pi. Okay? Now I want to find them, and we can sort of, I'm going to take this red dot off, and I'm going to just sort of put it, we have one answer at pi over 3. We have another answer at 3 pi over 3, which happens to be the same as just pi. And we have another answer at 5 pi over 3. Those are our 3 answers from 0 to 2 pi. If you wanted to now solve between -2 pi and 0, all you have to do is subtract 2 pi from each of these. Or you can think about your unit circle and say what they would be. If you have 5 pi over 3 here, this angle would be -pi over 3. If I have pi here, this angle would be -pi. And pi over 3 right here, if I'd calculate that angle, and of course you could subtract 2 pi from that answer to find out what that negative angle would be. Of course, you're doing fractions, so you need a common denominator. You'll see that you'll get -5 pi over 3. Now, one thing I don't want you to do as a shortcut here, this is a coincidence that each of the answers that we got from 0 to 2 pi are just negatives in our answer, just because of where they fell because of cos in quadrant 1 and quadrant 4. If you had answers in quadrant 2, the negative angle would be different. So don't just make them negative because it's between 0 and 2 pi. Yes? Okay, do you want to, you can come sit in one of these up here. That would be just fine. So those are the answers between -2 pi and 0. This question also says determine the general solution. And the general solution means work for all of them. Yes? Yeah. So if we're determining the general solution, what we've done in the past is we've found all our solutions between 0 and 2 pi, which were right here. And then your general solution, list them all and add 2k pi to each one, because that would give you all the coterminal ones. So here we have the general solution, which the question asked for. Here we have the solution from -2 pi to 0. So the questions you can do from your homework that are like this are 4, 8, and 9.